In this phone exercise, what we're going to be working on is a phone number normalizer. So what that means is we're going to take a bunch of phone numbers that are in different formats, and we're going to try to get them all in the same format. Now, the primary reason people tend to normalize data and to get it all in the same format is that it's much easier to find duplicates and things like that. So if we're looking at our database and say some of the phone numbers have parentheses, some of them don't, we might read them as two separate things. So even though a person can look at them and tell, oh, these are the same phone number, it's going to be a little bit trickier for our code to do it. And the best way to do that is to just get rid of all the formatting, just store the digits. And then when you want to print out phone numbers long-term, you just format those digits depending on, what makes the most sense. So in this application, we're going to first start creating some code to, well, not first. I guess first, one of the things we're going to do is look at how to create a database. And normally you'd probably do this manually, especially if you're using a hosted database or something like that in a production environment. You would go set up a database and then you would just use the URL in your application to connect to it. Or maybe you'd have some API code that pings maybe an AWS endpoint and creates databases that way. Usually in production, at least I don't generally tend to find myself creating databases with SQL commands or with database specific commands or anything like that. So it's not super useful, but we're still going to cover it. We'll look at how to write the normalization code for the phone numbers, and we'll look at how to test that. So I don't want to spend a ton of time on testing. That's not the main goal for this exercise, but we will at least see how to write a test and how to use it to make sure that our phone number normalizer is working, because this is a prime example of something that's very easy to unit test, and it's very useful because we know that that code is then working correctly and can catch all the edge cases. The next thing is we're going to look at inserting data into the database, reading data from the database, and updating data from the database. And we're going to do this we're going to be using SQL. So I wanted you to see how SQL works in a database, or as far as databases go. We use BoltDB in one of the task CLIs. So for this one, I wanted to use SQL. And there's different variants of that. The most common ones that I see tend to be MySQL, Postgres, and SQLite. So we're probably going to try to look at those three. I'll try to cover all three, but it's going to kind of depend on time. The first version will probably only cover Postgres, maybe SQLite as well. And then once we get those two done, I'll try to come back and cover some others. I'm also going to try to cover different ways to use the database, specifically different packages. So the Go standard library provides a sort of like an interface or a shell that gives you ways to interact with SQL. But there's a couple other packages out there that people recommend. One is SQLX, and that's like, it's not an ORM, it's just sort of an extension of the SQL package that Go has. And then if you wanted to move into the ORM territory, there are things like SQL Boiler, GORM, and there's a bunch of others out there. So I'll probably over time slowly add different versions of this exercise so you can see all the different things out there and sort of compare them, see what they're like. But for for doing the exercise, use whatever you're comfortable with, or if you want to learn something new, go ahead and do that. But don't feel compelled to use the exact same things I'm using, because I'm basically just trying to give you, one way of doing it if you've never done it. Otherwise, do what you're familiar with. Make sure that, that works for you and you don't need to do what I'm doing. So if you want to write this on your own, start and do this in whatever order you want. I think I might have some sort of rough order outlined in the README. You can use that if you want, or you can do something slightly different. In the videos, I'm going to start with normalization and testing it. So the code to take in a phone number string, normalize it, get rid of all the formatting, that sort of thing, and spits it back out, and I'm going to write code to test it. And I'm going to start here because I'm going to use it in pretty much all the other videos. So it's just nice to sort of get that done ahead of time. And then if I want to record, follow-up videos, I can do that for each different language. Or not language, for each different library or version of SQL. After that, I'm going to mess around with creating the database. And again, this is the part that I find less useful in the real world. Creating databases is just not something I do very, very frequently. There's code and libraries and packages like that that'll do it. Maybe as part of your test process, it'll recreate and delete a test database in between each thing. So there are cases where you want to do it. It's just not something I do a ton. After I have the database up, I look into inserting data into it. I want to take all the phone numbers we have, and I want to show you how to insert them into the database so that we can then use them throughout the rest of the exercise. And again, this is something you can do manually if you just wanted to manually insert them into a database, because that's not really what this exercise is. That's fine, but it's up to you. After that, we're going to look at how to read the entries. Like I said, we're going to look at how to read them, and then we're going to look at how to update them. So those two things. And I will definitely say that going back to the creating, Postgres is a little bit different than MySQL and SQLite for creating entries. And we'll see that in, I think, one of the early videos here, because I'm going to cover that in Postgres first. And I just want you to see it because it's kind of a gotcha that really messes people up if they're using Postgres with Go. And it's because of how Postgres differs a little bit from some other SQL databases. So I think that's everything. If you want to code this on your own, now's the time to stop the videos. Go ahead and check out the README and just go ahead and take a stab at it. We're going to start by creating a function that takes in a phone number and normalizes it. So it's going to strip out all the formatting and just return a string that has just the digits used in the phone number. Now, I say we're going to start with that. We're going to create the function definition. We won't implement it right away. After I create the definition, I'm going to go write some tests for it. And with these tests, we're going to see how they can really help us find bugs in our code. And, can sometimes just be really helpful, especially when you're writing a trickier function. This one's going to be fairly simple, but if you're writing something a little bit trickier, they're very handy at making sure, here are 10 different use cases I know I need to cover. And I think they're all a little bit different, a little bit unique. It really helps make sure that you're getting that right. But I do want to warn you that you shouldn't just rely, you shouldn't just rely on the tests. You should look at your code and make sure that it makes logical sense to you. Make sure that it's following the flow that you expected, the algorithm you expected to use to solve the problem. And if that's the case and it passed your tests, then you're probably fine. But I occasionally see people, they'll write tests and they'll just hack together some code that only works for those tests, but doesn't work for every use case. And that can sometimes be an issue. So we're going to start, we're going to create a main.go. And this is where we're going to have package main. And we're not going to break any of this into packages right now because I don't want to create a package with just one function or anything like that. We're going to just put all of our code in this main function, our main.go source file. So we're going to make this function. It's going to be normalize. It's going to take in a phone number, which is a string, and it's going to return a string. And for now, as I said, we're just going to go ahead and return the phone number. Actually, let's just return an empty string. I think that makes more sense so that we know this always fails. So we've got this. We want to write tests for it. So that means that we need to create a test file. Well, the way you make test files in Go is you just create whatever your file is _test.go, and it'll be considered a test file. It should only be included whenever you're doing whenever you're compiling code to run tests. Whenever you do the binary, this code shouldn't be included. And sometimes you'll see tests that don't have, for example, maybe instead of main_test.go, it'd be something else. That happens occasionally. Usually the file that has all the stuff you're testing, you'll have a test file that sort of maps to it. But sometimes there are tests that need to test things in multiple files or other stuff like that. So you name them a little bit differently. The next thing is the package. And for this, you'll see people go one of two ways. They'll either use the same package that their code that they're testing is in, which is what we're going to do here. Or sometimes you'll see people do something like main_test, or just some other package that is meant to be a test-only package. And the reason they'll do this is because they want to test things from an outsider's view. So they can only see exported functions then. They can only use things as somebody who is using your library would be able to use it. So that's sometimes useful when you want to just sort of test them from that perspective. It's also sometimes useful for there are other weird use cases like cyclical dependencies and stuff like that where they can be used. But in this case, we have an unexported function. There's no real reason to test outside of the package for what we're doing. So I think it's fine to keep this in the same package. And then we're going to create our test, which is going to be test normalize. And it's going to take in a testing.t, which is what every test takes in. And in here, we're going to do some table-driven tests, which basically means that instead of writing 6 different individual tests, we're going to create a table or a struct. It's going to be a slice of structs that basically define test cases. They define the input and what we expect to be the output. And we're just going to use those to iterate over each one and run a separate test case and verify we're getting that output with each input. So we'll start by declaring our test cases. And these are going to be, as I said, a slice of structs. And we could declare this struct type up here. It could be something like type normalize test case struct. And it's going to have something like phone number and a string, which is a string. This is what we're going to provide as input. So you could just say input string, want string. So want is what we want as our output. You could declare this all up here. I'm actually going to just declare it inline here because I don't really want to pollute this namespace with a bunch of different types that we don't need. I think it makes more sense here just to do them inline like this. After you've done it inline, you can declare them. So if we had kept the normalized test cases here, down here, we'd be doing something like normalize test cases or case. And then in this, we'd be declaring the individual normalized test case objects because this is a slice. We're going to go ahead and just do it this way. And since we did it like this, we can just put curly braces. So this is the same as what I just sort of showed you, but it's using it with this inline type. And here we want to use all of the test cases from the README. So I'm going to go ahead and grab them here. I'm going to paste them. And then I'm going to do a little bit of multi-select magic just to go ahead and quickly. So I'm going to put this all in quotes. So we've got the input string, comma. I'm going to paste the exact same thing on each line. So we've got the output, and then we'll eventually have to format that. Write curly with a comma. Then I'm going to go to the front of each line and put this curly. And that should give us all the test cases. So we need to go through here and clean these, but we'll do that here in a second. It's fine letting it be. So now that we have all the test cases, the next thing we're going to do is iterate over them, and we're going to run a test case for each one. So we're going to say for each test case in the range of test cases, here we want to go ahead and do t.run. And we need a name for the test that we're running. So this is kind of these are considered subtests. So they're, inside of the test normalize, we're running some subtests. And we need a name for that subtest. Well, the easiest way for this particular situation is to just go ahead and use the input as the name so that we know what the input was whenever things go wrong. So I'm going to do tc.input. And then inside of this function that we're going to run for the subtest, we can now access this tc variable as, because this is a closure. So we can access this tc variable and use the input and the output in our test. So we're going to say the actual output is going to be normalize tc.input. And then we're going to go ahead and say if the actual output is not equal to what we wanted, so tc.want, then we're going to t.errf, and we're going to say got %s, want %s, and what we got is going to be actual, and what we want is tc.want. I think that's everything for this. I'm looking it over. So assuming I got this all right, we should be able to go test. And you'll see here that all of our test cases are failing. Well, that's kind of expected because we're always getting the empty string. Clearly that's not what we want every single time. So, we can go ahead and fix that. The other thing is that all of these test cases, or all the wants over here, are not correct. We need to go ahead and manually fix these up. So I'm going to go ahead and delete these, all these special characters manually. And this is, a little bit tedious, a little bit annoying, but it's fine. I will say that these two test cases are pretty much the same. They have different digits. That's about it. So I'm going to go ahead and delete one. And then looking at this, I think all the rest are mostly different. They have different types of variations in formatting, so I think that's fine. All right, so that should be a good solid set of test cases. And we're going to go back to our main.go. And here, for now, I'm just going to have this return phone. And I'm going to show you that now that we've done that, some of these test cases are passing. So if I put -v, which is a verbose, you'll see that we've got this test case passing, and we've got this other test case passing. So if we go back to our code, you'll see that what's going on is this line and this line are both just providing already normalized phone numbers. So we could actually get rid of one of those if we want, just to clean this up a little bit. But it's fine that this test is passing because technically our code works for that test case. If it's already formatted, our code works. Otherwise, it just doesn't. So we're going to go ahead and fix that. So to do this, we're going to we want to go through the phone number and we want to find every character that's not a digit. So between 0 and 9, or between in one of these. So as long as it's one of these things, we want these. And anything else is going to get replaced with an empty string. So there are a couple different ways to do this. I'm going to show you two of them, I think. One's going to be using regex, another is going to be iterating over the string and looking at each character individually and building a new string. So let's start with the second one because regular expressions are useful, but how do I put this? There's a common meme of, you have a problem, so you use regex to solve it. Now you have two problems. And the reasoning for that is that it's very easy to mess things up or to miss corner cases and things like that. So I will talk about them a little bit when we get there, but for now we're going to go ahead and just go to the manipulating the string version or iterating through it. So we're going to do var buff. This is going to be a byte stop buffer. I'm creating a byte stop buffer because I want to be able to build a new string as I go through the string. And I could just go ahead and create an empty string like var out is equal to the empty string, or just out : equals empty string, sorry. And I could just add to this with the plus operator. That would be fine. It's just not super efficient. So if we had really long data, it might be slow. So I'm going to go ahead and use the byte stop buffer. I also like showing people how byte stop buffer works because it's something that sometimes people just don't dig through the standard library to find. So we're going to go ahead and range over the phone. I need range here. And I do want to mention, I think I mentioned this in another video, when you're ranging over a string, you're going to get runes here, and they're a little bit different than just regular characters in some languages or bytes, so just be aware of that. What we're going to do with our characters, we're going to say is if the character is greater than or equal to 0 and less than or equal to 9. So if it is both greater than or equal to, or greater than or equal to 0 or less than or equal to 9, so if it's in that range of 0 to 9, and this works because I know that 0 is the first ASCII character in that sequence of 0 through 9, and then it's followed by 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's just how those characters are mapped to ASCII values. So I know this is going to work. And I'm actually going to show you, once I get this working, a bug that you could potentially introduce to your code and how the tests help find those. So if the character's in between these, what we want to do is buff.add. Let me go ahead and just save real quick. Why is this complaining? Oh, I need ch is less than equal to. Okay. So I wanted to save just so I could get the import so that I could get some autocomplete here. I want to, I think it's write. Yeah, it's write rune. We want to write rune. So we're going to go ahead and put write rune, and we're going to pass in, not buff, we want to pass in the character. So if it is between 0 and 9, we're going to go ahead and write it to our buffer. Otherwise, we're not going to. And then that should cover all of everything we need to do here. So the last thing is returning the string that we built. So we're going to return buff.string, and the byte buffer has a string method on it. So it's really nice to just take whatever you wrote into the buffer and convert it into a string. Okay, so let's go ahead and test this. It looks like all of our tests are passing. We can put -v here, and you'll see each individual run, they're all passing. So our code seems to be correct, but I want to show you how you could potentially have bugs and what they look like. So for instance, let's say you forgot about 0 and you put a 1 here. So if it's between 1 and 9. Or let's say you thought that the way that the characters are ordered was 1, 2, 3, 4, 5, 6, 7, 8, 9, then a 0. So maybe you put a 0 here or something like this. Well, let's start with the 9 version. If we were to run our code, you'll see here that at least one of these test cases is failing. And the reason that's happening is because when we wrote this code, we wrote it in a way that basically all the digits are used. So if you ever have something like this that's invalid, you'll see here that we're just trimming out the 0. So that's what's going wrong with this, is it's not including that final 0, so our test case fails. So we can also change this, say you would put 1 to 0 instead, like I just said. You'll see a lot more of these test cases fail. Well, that's because 0 is actually a lower character code than 1, so it's impossible for this character to both be greater than or equal to 1 and less than or equal to 0. That just doesn't work. So if we change these both back, our code will go back to passing again, and we've got this all working. So you can see here that these tests will already help you catch some smaller, really easy to make bugs. Next, we're going to see how to implement the same normalize function, but we're going to be doing it using a regular expression. And regular expressions are kind of a mixed bag. They can sometimes match things that you don't expect. You can make mistakes with them fairly easily and not quite realize it until you get some weird edge case. So I will just say be a little bit weary when using them. They're not a tool that you should just sort of pull out and use all the time, but they are useful. They're useful a lot in very many cases. It's just something that they can be overused and lead to other bugs. So we're going to go ahead and just copy all this code, and I'm going to comment it out down here because at the very end I want to have both versions available so that if you do look at the source code you can see how both are working. Inside of here, I'm going to go ahead and delete everything, and we're going to start by creating our regular expression. So we're going to say re:= regular expression dot, and here we could either do a compile or a must compile. Now, normally you shouldn't be doing things like must compile inside of a function like this where it could panic. The reason I'm going to be doing it now is, one, we know we're testing this code, so we know that if this actually does panic, our test will cover it. The second thing is, basically, whenever there's a compilation error with a regular expression, there is no real way of recovering. The only typical, you could maybe fall back on not using a regular expression, but generally speaking, if there is an issue compiling a regular expression, it means a developer needs to come find the code, figure out what the heck the issue is, and fix it. So you'll see here that if I actually create, this is an invalid regular expression, if I create it, and then what we're going to do is re.replace all string, and this is going to use the regular expression. Whatever it matches, it's going to replace with whatever we provide. So we're going to pass in the phone number, and we're going to eventually be matching all non-digits, and we're going to replace them with the empty string. So we'd be doing something like this, and that's how this would work. But you're going to see here when I go to test this, that we get this compilation error. So what's happening is it's trying to compile this invalid regular expression, and it's panicking. And that's what I meant by, this must compile will get rid of the error that returns, but it will panic if that error is actually present. So we're going to go ahead and replace this. There's a couple different ways to write this regular expression. The simplest is probably something like this, where we're saying we don't want any of the characters between 0 and 9. So those are just digits. So we can go ahead and just go test, and you'll see that this passes. All of our test cases work, and it seems to be good. Another way you could do this is just the capital D. So there's a lowercase d. This is like it's generally speaking, it's just /d like this. And in regular expressions, this means to match all digits. So that definition can vary based on the language and some of the other stuff, I think. I'm pretty sure in some, I don't know if it's the language or what exactly specifically specifies it, but there are times where it might match other characters outside of the normal English alphabet that are digits. So it's just something to keep in mind, especially if you weren't expecting that. In Go, I don't think that's the case, but it could happen. And then the capital D is the opposite of that. Anything that does not match in the original D class, the capital D class will match. So we need this first backslash to escape the second backslash. So we've got backslash, and then we want capital D. So we're saying any non-digits. And then our regular expression is going to say replace all occurrences of a non-digit with this empty string here. And again, we can run this and it's all passing. So that's it for our normalization code. I'm just going to keep the regex version, the top one here. But either one's fine. You can use whatever you think is best for your code, whichever one you understand a little bit better just pick it that way. You could even benchmark the two and pick the faster one if you wanted, but I don't think that level of optimization is going to be too important, especially for the application we're writing. I think the SQL database connections are probably going to be slower than all of this, so that's probably not a major deal. All right, in the next video, we're going to go ahead and look at the SQL stuff. So, if you want to learn about that stuff, jump to the next video. We're going to start off, we're going to be using Postgres, and we're going to be using the database, let me look it up real quick, database SQL package that's part of the standard library in Go. So this is what we're doing for the first version of, setting everything up, writing, reading, and doing all the stuff with the database. So when we start with this package, when you're reading at the very top of the docs, you'll notice that it talks about how this package provides a generic interface around SQL or SQL-like databases, and the package must be used in conjunction with a driver. So if we come here and look at the drivers, what are these drivers and what are they doing? So the SQL package doesn't actually have code that's specific to connecting to a database, doing things with it. It has a lot of different things built into it that are standard for doing database stuff. Like it'll have objects for iterating over different rows, some functions around that, stuff like that. But it doesn't actually connect to the database. It doesn't have the code that tells it how do I interact with a SQL data or a Postgres database versus a MySQL database, et cetera, et cetera. So the way this is implemented is somebody who wants to write a driver for some specific database. So say if you came and created your own SQL database, you could actually come here and write a driver. Well, what this driver does is it registers a driver to the this database SQL package. It registers a driver with this, there's a register function somewhere here. So it uses this register function. It registers this driver.driver type, and it can be used then by somebody who's using the SQL package. So that's what all of these packages here are doing. They are writing all the code for a driver implementation, and they are registering it whenever you import them. So what you need to do whenever you are using SQL with Go is you need to not only use the SQL package, but you'll need to grab a third-party library. You'll need to install it. You'll need to make sure it gets imported in your code so that the driver gets registered. And then once you've done all that, you can use it to connect to the actual database and you make those connections. And it sounds like a lot, but it's really not. So this page is just listing drivers for different versions of databases, different databases, there's a little bit more details here. For instance, whether or not it's pure Go or CGo is interesting to know just because anything that's pure Go is generally going to be a little bit easier to install on different systems because you know that the Go code will be compiled for every system. Anything with CGo might be a little trickier depending on the operating systems you're using and stuff like that. So you might have less luck with those. The other part is this asterisk at the bottom. Anything with that means that it passes this compatibility test suite, which is linked here. And this is just a series of integration tests, that sort of thing, to make sure that they have most of the features implemented and all that sort of thing. So to start, we're going to be using Postgres. So I like this libpq. It passes the compatibility test suite. It is written in pure Go, and I prefer Postgres because it's open source. I can use it for free in all of my production servers and stuff like that if I want to. It's the one I'm most familiar with, and it just seems to work pretty well for most of the projects I have. So with libpq, we're going to be going to the docs. You'll see here if you click this link at the top, it'll bring up the Go docs for it. And it'll have a little bit of information here about how to connect to the database. I will warn you that this first string is something that tends to throw people off, so I will try to cover that here. And while we're talking about errors, I have a lot more articles on my website at calhoun.io that talk about Postgres with Golang. They have different common errors. I have another article that talks about, you'll see this later when we import a package and don't actually do anything with it. It talks about why that happens and how it's actually registering the driver behind the scenes. And we'll see all that while we're going through this, but I just want you to know that if you get stuck, this is probably a good place to start, or you're welcome to reach out. I'm happy to help. Or if you go to the Go forum, people there are generally pretty helpful too. Okay. So going back to our code, we're going to be writing code here And we're going to be connecting to a Postgres database. Well, we're going to be connecting to Postgres. We're going to be creating a database, and then we're going to be, once we create the database, we're going to go ahead and connect to it and start creating tables. So to do this, I'm just going to put this probably all inside of a main function for now. That way we can run this code. And we need to install the libpq package, the one that I brought up here. So we're going to grab this link, come back, bring up my terminal. We're going to do go get-u github.com/libpq. So this will get us the package, and then we're going to go to main.go. And this is one of those weird things I was talking about. We need to import that package, but we're not actually going to use that. So we're going to do underscore github.com/lib/pq. So this is where most people are like, why are we doing this? What is going on? What's the point of this unused import? So the underscore here, that is the blank identifier is what it's called. Got to make sure I get that name right. Whenever you put it in variables, you've probably seen that. It just means you're not going to use the variable. Whenever you do it with imports, it means I need this imported, but I'm not using the package. I'm not actually going to call any methods or types directly created inside of, or functions or types directly created inside of that package. So what's going on is blank identifier. Yeah, I actually have it here. So I've got this article that goes into this all in more detail because it was something that was a little bit fascinating to me, and I went for a long time without ever looking into why this was the case. And then I finally just dug into it, and it's pretty obvious once you see it, but it's just not, it's not something you might not just know instinctively. So roughly what's going on is inside the PQ package, whenever you call it, it has an init function. Inside of that init function, it calls SQL.register and passes in something like Postgres followed by whatever driver it has. So it's something like pq.drv, something like this, because it has some driver there. So all it's doing inside of that init is registering a driver. And by importing it, you make sure that code actually gets run. Now, realistically, I think it would have made more sense long-term if it was probably something like we actually had to call this in our code, SQL.register, Postgres, and then pass in something else. Or maybe there's another design that makes more sense. There are downsides to every approach, regardless of which one you end up doing. So I can't say one's definitively better. But I just say that in the sense that this part here kind of feels like magic to some people, and that's not always a good thing. A lot of times it's bad because people are confused. They don't understand why things are happening. They just know they have to do them. And those usually can lead to issues or bugs down the road because people just don't know what's going on. An example of that is if you imported two packages that both registered Postgres drivers, you might not realize it. You might not understand that one of them is potentially overriding the other one, giving you a different driver than you're expecting. So there's all sorts of weird situations where that could lead to issues if you just aren't aware of what's going on. Okay, so we want to create a database. To do this, I'm going to create some constants first. And I'm going to warn you that my constant values are probably going to be a little bit different than yours depending on your setup. We want a host for this is all for the Postgres database. So I've got localhost. I've got a port, and I'm going to make mine 5432, which is the default. I need a user. I know my Postgres is set up so that the user is my user for my operating system, which is just John. And then I need a password. I'm going to put a fake password here. My database is actually set up so that I could just use this password. It'll be fine. But a lot of a lot of different databases might have no password. Maybe they're using maybe they're using just the user you're logged into Linux with to authenticate you. Another instance is, or maybe you just need to go find out your password. So figure that out. I can't really tell you for sure. I can say that there's definitely an article here that talks about installing on Ubuntu, and it'll at least talk about how to make it so you can use a password with a Postgres install there. And if you're using another variant of Linux, you'll probably have to tweak it a tiny bit. I think some people have talked about in different variants, sometimes you have to make sure that certain services get started up or something. So just keep that in mind as you go through here. So I'm going to use your password and then a DB name. Let's do Gophercises phone. I think that's fine. So this database isn't created, so I'm just going to give you that information now. But I'm going to write some code to create it real quick just so we have it. If you go to the docs here, you'll see that they talk about how to build these strings to connect. You can also use URLs, which you'll see here. It's really up to you as to what you want to do. I'm just going to go ahead and build a URL or build a string that I know I can connect with, and then I'm going to use that. So I'm going to say PSQL info is going to be, I want to do sprintf, and I'm just going to say host equals %s, port equals %d, user equals %s, password equals %s, SSL mode equals disable. So SSL mode equals disable is something I'm putting in here because, as I said, it's something that people usually have a bug with. Locally, my Postgres isn't set up to use SSL mode. So I need to put disable here because I think the default is, where is it? If you don't put SSL mode, right here it is. Whether or not to use SSL, the default is require. So if you don't put this part here and you just leave that part out, Postgres, the driver here, will assume that we're using SSL mode, and it'll probably error if you don't have it set up. So just something to keep in mind. All right, so here you want host, port, user, password. So that should set up that PSQL info string. And now what I'm going to do is I'm going to use that to connect to the database. So this is going to be db error is going to be sql.open. And I need driver, which is Postgres, and a data source name. This is just the PSQL info string that we created. And then I'm going to say if the error is not equal to nil, panic with the error. Otherwise, db.close. And we're not going to do anything here. You'll see, oh, and you're seeing these red things on the left because I have a test file and I'm not testing this code right now. So just ignore those. So you'll see here that we've got db.close. We're not doing anything. Normally you defer this db call, or it's very common is what I should say. You do something like defer db.close. I'm not doing that right now because here in a second, we're actually going to create the database and then we'll close the connection. We want to close the connection before we get to the end of this main function because we're going to open it back up again. So we have all this. Let's just go ahead and go run main.go. And it looks like no errors, so we don't really know if it's working. I can tell you right now that even that wouldn't have necessarily errored because we'll get to that in a second. All right, so while the database is open right here, we want to drop the database if it's there maybe and create a new one. So let's just go ahead and add a function for that. So this takes in a sql.db, and it's going to take in maybe a database name, and it'll return an error. And inside of here, we want to, let's just start with creating the database. So I'm putting underscore error. It's going to be db.exec because I don't, you'll see here db.exec, it has a sql.result is one of the possible return values. I don't, excuse me, I don't need that result. I'm not going to do anything with it. So for this exec, I can just underscore it. All right, what's the query we're going to do? We're going to do let's do create database and then plus name. So before I move on, I'm going to go ahead and say, normally you shouldn't do what I'm doing here. So here I'm concatenating a database or concatenating a string, and this could lead to all sorts of SQL injection. The reason I'm doing it here is because I know that I wrote the database name myself. I know that it's something that's safe to do this with. And as far as I'm aware, I don't know how to make this actually use like question mark parameters or something like that. So, excuse me, normally with SQL, this package here, the reason that we use this interface is it has a lot of helpers that allow us to, here's an example, db.query, select name from users where age equals $1, and then you replace it, you put the age in there. Well, this is nice because it allows us to not worry about, random injection attacks. It allows us to just skip over all of that because the package itself will handle it for us. And that's the biggest thing about using this package or using a package like this to compile all your SQL queries is that you don't have to worry about these injection attacks doing things that'll drop your table. And again, I think there is, let me look for it here. Maybe this one. Yep, this is one of the articles that I talk about SQL injection, what it is, how it's a big deal, and all that sort of thing. So normally you wouldn't want to do this. Bad thing, it would end up causing issues. You could have SQL injection. But for this particular instance, I think it's fine. And I just don't know how to make it work the other way. So for now, we're just going to let it be. It's just not something I do very often, is create a database, in code. So from here, I'm going to say if the error is not equal to nil, we're going to return it. Otherwise, we're going to return nil. And I could have just returned the error here probably. So that would be fine, but I might want to add more to this later, so I'm just going to let it be. So then here, we're going to do reset DB. And technically, this is creating the DB. So same as create DB. And we're going to pass in the DB we have, and our name is going to be DB name. So let's do error equals this. If the error is not equal to nil, panic with the error. So let's go ahead and run this again. And it looks like everything went well. So I will warn you, if you run this a third time, you're gonna get an issue. So what's happening is this database already exists. So it's gonna give you an error because it obviously can't create it. So maybe we wanna make a reset DB function. And it's going to do the same thing, except it's going to drop the database beforehand. So here we'll do underscore error, colon equals db.exec, drop database if exists. And again, we're going to do plus name. If the error is not equal to nil, return the error. Otherwise, we're returning create DB, DB and name. All right, so we've got create DB, we've got reset DB. Up here, we can do reset DB if we want to. We can run this all over again, and it looks like it drops our database and creates a new one. So from there, we want to disconnect from our database, and we want to start creating tables. We need a phone numbers table in order to be able to store these phone numbers in it. So we're going to look at how to create the table. So to connect to the database again, I told you we're doing db.close here. We're not deferring it. Now we're going to do db underscore error or comma error equals SQL.open Postgres. Well, we want to do the PSQL info, but we're missing something here. So we need the database name as part of this PSQL info string we created, because if you look at the PQ docs, you'll see here that normally they put the DB name as part of that. So what we're going to do is we're going to slightly modify that string here. We're going to say PSQL info is equal format.sprintf %s. We're going to put PSQL info there. We're going to put a space. And we're going to put DB name equals %s, and then put PSQL info DB name. So now we've got all the pieces we need to connect to a specific database, and we can go ahead and do that here on this line. And we're going to, again, if the error is not equal to nil, this is actually getting a little tedious, so just to speed things up, I'm going to go ahead and do if error is not equal to nil, panic with the error. And this isn't something I do all the time, but for this particular instance, I think it's going to just speed things up and it's fine. So we've just got this must function. All it's doing is just checking if an error is not nil. And I don't do this all over the place. In main.go, it's sometimes useful just because that's really the only other option at this point. Not the only option, but it's what we're going to do with these errors. We're just going to panic with them. Okay, so we want to go ahead and close this database connection if we, or whenever we're done here. So we're going to say defer db.close. And this one we are deferring because for the rest of the main function, we're going to use the same connection and we don't need to close it until the end of this main function. So from here, we can sort of move on and use the database, but I want to make sure that we're connected correctly. And SQL.open doesn't actually, I forget where it says this in the docs or whatever, but basically SQL.open won't actually connect to the database and verify that connection is working. So we need to do something like down here, db.ping, which will go ahead and it'll return an error. So we can do must db.ping, and this will make sure that we can actually ping the database. So now I'm going to go ahead and run this all, and there's no errors, which means that it looks like everything's working fine. If we weren't creating the database correctly, it should give you some sort of error. So I think we have our whole database created, we're connected to it, and we're ready to start creating the tables. Next, we're going to go ahead and write code to create a database. And again, we're not going to be using the normal way that you'd replace variables inside of a SQL statement. And again, the main reason for this is that generally speaking, you shouldn't be creating random tables provided by the users. I don't know of many useful applications where you're just letting users create database tables. That seems pretty rare. So for generally speaking, all of the SQL injection prevention stuff is going to come into play later when we start writing queries about searching, inserting records, things like that. That's where they're really useful because that's generally where we're taking user data from web requests and starting to use it. So for this function, I'm just going to write it here. We're going to call it function create table. It's going to take in a SQL.db and it's going to take in a table name. Okay, so from here, we want to create a statement that we're going to go ahead and exec. I think it's easier to do this if you format a little bit more familiar or a little bit closer to how you normally do SQL. So we're going to go ahead and do statement equals func.sprintf. And then instead of double quotes, we're going to put the backtick here, which allows us to go multi-line. And I'm going to go ahead and just hit enter twice. And then here, I know I'm going to pass in name. So I'm going to go ahead and add that. And I'll fill out the rest of this. So I want to do create table if not exists %s, and this is going to be this name part that we're passing in. And then I need to sort of define that table. So I'm going to do this. And then in here, we're going to say, we want an ID. I think a serial ID makes the most sense because if we want to update entries, things like that, we need some sort of ID. So we at least need an ID. I think we're also going to want just a value, which is just going to be the phone number value. Because, so you can see this create table function is really not that super useful because all we're doing is creating a table with just values. So maybe it actually makes more sense just to say create phone numbers table, something that's really long, but whatever. And we can probably get rid of this and just hard code in the phone numbers. And this again is another reason why you don't generally just create random tables, because the user would have to provide you with all the different types of variables and fields that you want on that table. So really not that useful. So anyway, we want an ID for our phone numbers. We're also going to want, I can get rid of this sprintf. We're going to go ahead and delete that. So sorry, we want the ID, and then the next thing is the value. This is going to be the actual phone number value we store in the database. So I'm going to make this a varchar 255. I think that's going to be plenty big. And I'm doing this because we're storing strings, not integers or anything like that. We have all these weird formats we permit, and we also don't want to sort of worry about, will this overflow if we get an international number with a really big prefix. So I think it's fine just to go ahead and just make it a string. Okay, so now we want to execute this. So to do this, it's the db.exec, just like we were doing before. We're going to pass in the statement, and then we're going to just return the error. And then up here, we can do create phone numbers table and pass in the DB, and we'll make this a must as well. And we shouldn't need ping at this point then, so I'm going to delete that. So let's go ahead and go run this. And now I have a bug. All right, oh, this extra comma, that's, so in Go, a lot of the times when you have like multi-line fields here, you'll put a comma after every one. In many other languages like SQL, you don't do that. So just a bad habit. Well, not bad, just a habit from Go is extending over to SQL. All right, so this should have created my database table. Should have dropped my database, should have reset the DB, which would drop the database if it exists, then create a new one. Then it should have created this table if it doesn't exist, and it shouldn't have existed. So I'm going to open up this Posteco app, and I'm going to connect. I'm going to choose. So I've connected to the database that we just created, this Gophercises phone. And in here, you can see it has a phone numbers table, and it has an ID and a value. So, now that we have this, moving forward, we can occasionally use something like this to visualize it. We could have also Gophercises phone, I think is the correct way. There we go. So we could do select star from phone numbers is what we called it. And you'll see here that we've got ID and value. Those are the two rows in this database. And there's two columns, and there's 0 rows. So we've got this database created, we've got the table created, and we don't have any rows in it, but everything seems to be working fine there. So what we're going to look at next is how to insert records into that table. Next up is inserting phone numbers into our database. And this is one of the ways that Postgres is a little bit different from the others, from the other SQL databases. You'll see what goes wrong here shortly. I'm going to show a demo of it. But I will say that this is, it's something that's just different with Postgres. The database is just designed differently than some of the other SQL databases. So it's just something to keep in mind if you're using Postgres. Okay, so we want to insert phone numbers. So we're going to go ahead and write this func insert phone. And it's going to take in SQL.db again, and it's going to be a phone number, which is a string. And we're going to return an int and an error. And we're probably not actually going to use this int, but the goal here is to return the ID of the newly created phone number. And it's something that tends to be a little bit more useful when you're working with, a web application or something like that, where when somebody signs up, maybe you want to get the ID back, or so, especially if you're working on an API. If you create some sort of resource, oftentimes you'll send back the resource they created with the new ID and some of the other stuff, so they can actually reference it in the future. So in here, we want to insert this phone value into our phone numbers table, and we want to get the ID back from the database after it's created the phone number. So we're going to do statement is going to be insert into phone numbers value, then we're going to do values $1. So this $sign thing here, this is something that I've seen every driver does a little bit different, it seems like. But the basic idea here is this $1 will get replaced by the first variable we pass into the exec or query functions. And you'll see that we're going to use exec first, but you'll see later when we're using query and query row. So this is how you prevent SQL injection, is you're using this $1. So some drivers will use question marks, and it'll just replace every question mark in order with the variables you passed in. The libpq one uses the $1 for the first variable you pass in. You could do $2 for the second variable passed in later, and it just goes in order that you pass them in to the query or exec statements. So the way that works is we're going to do result, error, equals db.exec, and we're going to pass in statement, and then the phone number. So this phone number part is the argument that I'm talking about, where it's going to be, this is number 1, and then if we did ABC, this would be number 2. ABC is number 2. And if we did 333, that would be the third one. So up here we could do number 2, number 3, and they would get replaced with this ABC and this 333, but they would be escaped so that they aren't going to cause SQL injection attack. Like, they aren't going to allow SQL injection. So you can do as many here as you want. And then I don't know if this is the actual reason why, but I'm assuming that the reason these start at a 1-based index instead of a 0-based is because technically the 0th argument is the statement. So everyone after that starts at 1. That's at least the way I always remember it. So I know that, we're starting at 1. Okay, so if there is an error, we're going to return -1 and the error. So we're going to return an invalid ID in the error. Then we're going to say ID, error is going to be result. So this is, whenever you call db.exec, it returns this, let me see if I can find it here, this result type. So if I come down here and find it, the result type is an interface, and it has 2 functions, last insert ID and rows affected. So those 2 are there. Usually last insert ID is the ID of whatever the last record you inserted into the SQL database. So we're going to go ahead and try that here, and this is where we're going to see that error I talked about earlier, where Postgres is a little bit different. So if the error is not equal to nil, return -1 error, and finally return int ID nil if there's no errors. So is this, I spelled statement wrong here. Okay. So I think that's everything. We're going to go ahead and do must insert phone DB, and we're just going to go ahead and use 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 as the phone number for now. And we need to actually do this a little bit different. Okay. Because this returns an integer and an error, we couldn't just use the must function. So now that we have all that, let's go ahead and go run main.go. And you'll see here that we're getting this panic. So the panic is because of our must function, but this is coming from an error, no last insert ID available. Well, this error is coming from this insert phone function. Specifically, it's coming from this result.lastInsertID method call. So what's going wrong here is that in Postgres, whenever you insert a record, it doesn't by default return the ID of that record. It doesn't just do that automatically. So this is something that MySQL and some other databases do, and as a result, they can take advantage of this last insert ID field, or whenever they're returning something. So Postgres can't do that. It's just not there not supported by the database. And the only way to actually get the value back is to add something like returning ID here. So, if you're using a different field for IDs or whatever else, you could have something else returned. But this is saying that I want to get the ID back. Well, I actually don't know if this would work or not. I don't think it does. But so the Postgres driver can't just add returning ID to every single statement you have, because not all your statements are going to have need an ID. For instance, we use the exec up here or down here when we create a table. Well, that's not going to return an ID, I don't think. When we're dropping the database, creating a database, these aren't things that make sense for returning IDs. So it can't just add that. So it's something that we actually have to add ourselves whenever we're dealing with the Postgres database. The other thing we're going to do here is, instead of doing exec, we're going to do query row, which is roughly the same as exec in the sense of how you pass in arguments to it. The big difference here is that it only returns an error. Well, actually, I take that back. It doesn't just return an error, I don't think. It returns a SQL.row. So if I look up query.row or query row, let me go to the top here. So we've got our DB, we've got query row here. This returns a row, or a pointer to a row. And then with that row, we can call things like scan, which will allow us to take the data returned and scan it into variables that we pass in. So what that's going to let us do is, if we come back here, apparently my keyboard's being weird. Give me 1 second. My keyboard freaked out, or my mouse, something got stuck, I don't really know. So anyway, with query row returning a row, we want to scan the returned ID into some ID variable. So we're going to go ahead and say var ID int, and then we're going to go ahead and scan into it now. So that's what we're doing here with the scan part. And then scan will actually return an error. So if we come back over here, if we click on row and we go to scan, you'll see that this method call can return an error. So all we have to do here is figure out if there's an error from that, and if there is, return -1 in the error. If there isn't, we're going to return the ID and no, and get rid of all of this. So now, assuming that all worked, I'm going to put ID at the front of this. Must error, ID equals, and then we'll put the ID. We need colon here because the ID is a new variable. So let's go ahead and run this, and we'll see we get ID equals 1. If we run it a second time, we're going to get the same thing. So that seems a little bit off. Well, what's happening is up here, we're resetting the database every time. So let's go ahead, and now that our database is created, as I said, this isn't something we do very often, we can actually go ahead and just get rid of all of this. So we don't need to open the database before we actually put the database name in. We don't need any of that. Actually, I'm just going to comment it out. And I'm just going to do that because I want this code to be available later on whenever people are looking through the source code. So I had to put a colon here on line 28 as well, because the DB and error variables are new variables at this point, whereas before they weren't because they were declared up here. So if all of that worked, we should now be able to create new records, each with a new ID. And you can also see that if we connect to the database and connect to the Gophercises phone table, and we do select star from phone numbers, you'll see that we've got all of these entries here. And granted, they're not unique or anything, but we do have all these phone numbers here. So they're definitely being inserted. And if we wanted to change this to 1-800-1234, something random like that, I think it needs more digits, but that's fine. We'll do 555-3214. I think that's correct. So now we can go ahead and just disconnect from here, run our code, connect back to our database, and select. You'll see that this bottom entry here is the same looking thing. So it's got that 1 at the beginning. That's a country code technically, but that's irrelevant for now. So we now have this inserting data into our database. So you can see here that you can use this $1. You can use $2, that sort of thing, to change the variables you're passing in to create your data. And even if a user were to pass in something that might normally cause SQL injection, because we're using this SQL package and we're calling db.queryRow and passing in the arguments this way, that's going to be prevented. So that's it for inserting phone numbers. Next up is going to be reading them, and then after that is going to be updating them after we've read them. So we're just going to read all the data from the database, and then we're going to update it. Although I guess before we do that, we should go ahead and here's the list of phone numbers we wanted. I'm going to reset the database. I'm going to uncomment all this and get rid of that colon. And I'm going to change this to be all of these entries. I'm going to do _error : insert phone db and then the phone number, and then I'm going to must error for all of these. And you can see this is super long. I think that's fine. I'm going to delete this last one because that was the 1-800 one we don't need. Get rid of that. But this should, I didn't mean : for all these. All right, now we should be able to insert all of these into our database. So I'm going to go ahead and run our code again. And I'm going to check real quick this. Yes, we have all those entries we talked about. They're all in our database. We've got 8 there. So now moving forward, we can kind of do what we wanted to do with this entire exercise. We can read the data from the database, normalize it, and then update it back into the database. The next thing we're going to do is write code that allows us to get a single phone number from our database. But before we go into that, I do want to say that a lot of what we're going to be doing from here on out in using the SQL package inside of the Go standard library is really just going to be writing SQL code. So it's not going to be very it's not going to be very Go specific. There's a couple things that will be, but most of it is really just writing SQL code. So that's one of the reasons a lot of people like this package and like this sort of design of using SQL within your applications, is that if you already understand SQL, you don't have to learn something new. You can just plug the package into your code and you just sort of connect the two without having to relearn something or learn some whole new ORM or something like that. And that's generally one of the complaints people have with ORMs is they got to learn this new tool that's very specific to what they're doing. There are other ones too, but that's one of the ones that you'll hear pretty often. So we're going to be using a function called queryRow, which we've actually seen here in the insert phone. Usually this is used whenever you are executing some sort of SQL command that you expect to return a single entity. Now, if you do it and you get multiple entities back, I believe the way this works is queryRow just gets the very first result and discards the rest. If there are no rows, whenever you call the scan function, which we did right here. So for instance, if this was a select statement, this scan would end up returning an error because the error doesn't return from this. The db.queryRow always returns a row object. It's not until you call scan that you start to see these errors that are like, I think the one's error no records. Let's see if we can find it here. Oh, I actually have this up. Good. Right here, yeah. So it says error no rows. Okay, so it's not no records. There's an error no rows whenever you try to scan, and there's no records there. So we're going to go ahead and just write a function here. We're going to call it getPhone. It's going to take in the SQL DB, and let's say we'll take in the ID of the phone number we want to look up. So this is the the ID column in the SQL database, and we'll return a string, which is the phone number, or an error. Technically returning both, but the error will be nil if we don't actually have one. So to start, I'm going to go ahead and just declare the number that we're returning, and if everything goes well, we'll return the number and nil for the error. So that's what we're hoping to do. So here we're going to do the same thing as before, where we do error :equals db.query row select star from phone numbers, where we'll do ID equals $1. So we're going to pass in the ID then. And this is going to return a row, like I said before. So if we call scan here, we can then get an error back. So we can do scan and number. So I'm putting ands in front of these and in front of this one because I want to make sure I pass in a reference to the variable we have. I don't want the value of number passed in. I want to pass in a pointer so that it can actually populate that number variable with the data. And oh, just so you know, I could have done this as row : equals this, and then done error : equals row.scan. So that's another way to do it if you want to break this into two lines. It's just a lot of times you'll see those two chained together. So once we have that, we're going to check to see if the error was not equal to nil. Return empty string and the error. So this is whenever something went wrong. Otherwise, we'll return the number and nil. And then coming up here, I want to do one of these. So I'm just going to go ahead and say ID up here. So we're going to get this ID. We're going to continue inserting a lot of these records. And then I'm going to do get phone, DB ID, number error, and we'll say must error, and we'll print out the number. And I'm just going to go ahead and prefix this with a number is. So with that, we should be able to go run main.go. And expected to destination. Oh, okay. So I know what's going on here. When we do select star from phone numbers, it's going to grab every field. So in this case, it's getting both the ID and the string, the number value that was stored in the database. So one way to fix this is to change this, select value from phone numbers, so we're only getting the fields we care about. Or if you wanted to keep it as this, what we could do is down here, put and ID, comma, and number. So we're giving it the two variables that we want to fill in. And in this case, it's going to be the ID and then the number. So if I run this, you'll see number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 with the parentheses. So let's go up here. This is the one that we inserted there, so it looks like that's right. Okay, so we've got this get phone number function working. Now we're probably going to want something that allows us to get all the phone numbers. And I'll warn you that the way you do this is going to vary. I'm just going to show you how to write code that will just get them all, regardless of how many there are. But typically in a really large database, you might want to do this in pages. So instead of looking up, maybe 1 million records all at once, you might instead want to write your code so that you're only getting 10 at a time or something like that. So your code could vary a little bit, but since I know our database is pretty small and I just want you to see how to do the query, we're going to start with just getting them all. So I'm going to do with func. And then I want to do, we'll say all phones. And we'll take in db SQL.db. And I don't think we need any arguments. I think if you wanted to pass in arguments, you could say like a min and max ID, to do like a page, or you could just say like a starting ID and maybe like a max number of things to get. There's different ways to do pagination depending on what you think works best for your scenario. I don't want to cover those here. I just want you to see how to do this. Okay, so what are we going to return? We're going to return a slice of strings, which would be the phone numbers, or an error. And then inside of here, we want to go ahead and use, instead of query row, which we have here, we want to use query, which is up here. It returns this rows object, which is a little bit different from a row. It's very similar in a lot of ways, but it's a little bit different. And it returns an error. So we're going to come back here and we're going to say rows, comma, error, :equals db.query. And here we're going to put select star. Actually, we only want the values. Well, I take that back. We're going to want both. Select ID value. You could use star here. I'm going to use ID value just to make sure if you have extra fields, it doesn't break this. From phone numbers. Well, if I could type today. Okay. If the error is not equal to nil, Then we're going to return nil error. Otherwise, we want to go ahead and move on. And the first thing I'm going to mention is that we need to close this rows object. So it has a rows.close here. So we're going to do defer rows.close. And technically, you might want to check for errors whenever you close this. So that really varies depending on what your situation is, how important it is to catch this. I think for now it's fine just to defer it and just let it be. But it's the same as opening up files in your operating system and things like that. Those closes can often return errors, so sometimes you want to check for them. Okay, so going back to the docs. If you look at this, you'll see there's a for loop here where it says for rows.next, and then inside of here, we always do a scan. And then once we scan, we'll get some data, and this rows.next will just keep on iterating over these. Rows.next will return false whenever there's no more entries, or I believe when there's an error. So it's either or, which means that whenever this for loop stops executing, we're going to want to go ahead and check for errors, which you do with the rows.error. So it doesn't return an error itself with rows.next to make iterating over the cycle, iterating everything much easier, but it's going to make it so that whenever it does exit, you want to check to make sure there's no errors. So we could copy this code if you want. I'll go ahead and do that and bring it over. Paste it in here, and you'll see we've got for rows.next. Another thing that can confuse people is you call this before you actually access the rows object. So it's designed so that you don't have to do all of this code. Since there's no do while loops or anything like that in Go, you don't want to do rows.scan and then have to do a for loop with this. So this way, it just allows us to write a simple for loop. So in here, we want ID and number. Actually, we want our ID int, our number, and this is going to be a string, and that looks like the definition up here of what we're returning is wrong. So let's go ahead and create a type phone number struct, and I'm just actually going to call this type phone. It's going to have an ID, which is an int, and it's going to have a value or number, which is a string. And I know that a lot of these variables, I call it number sometimes, I call it phone sometimes, I think. So if this is production code, I definitely want to clean that up, but for now I'm just going to kind of let it go. All right, so we've got this phone, and we're going to return a slice of phones. All right, so outside of here, we want to be able to return this. So I'm going to say var ret. It's going to be a slice of phones. Then inside of here, what I'm going to do is I'm going to say var p phone. And then we're going to go ahead and do the scan. We know that we want to get the ID, so and_p.id and p.number. So that should get the ID and the value, which is the phone number. And if the error is not nil, we don't want to log. We want to go ahead and return nil, error. Now, there might be cases where you don't want to cancel at this point. Maybe we scanned 3 rows correctly and we want to return partial results. That really depends on your code and how you want to handle it. I'm just going to return nil for now. All right, finally, we need to add this phone to the ret slice that we have up here. So we're going to say ret equals append ret p. And then down here, we're still going to do the same if there's rows.error and we want to return something here. So we'll return nil error. Otherwise, we'll return ret nil. So, assuming this all worked, and I haven't tested it yet, so we're going to find that out. We should be able to query all the phone numbers. So we're going to go ahead and say phones error is going to be all phones. And we'll pass in our DB. We'll do must error. And then we'll do for phone or P in the range of phones. I'm going to do printf, and I'm going to do %+v with a new line for each phone. So this should print out the field names along with their values. All right, so let's go ahead and run this. Okay, so you can see all these phone number objects are being printed out where we've got the ID and the phone number. So that means that we've got code to query for a single phone number, and it just returns the phone number value because if you passed in the ID, obviously you already have it. And whenever we query for all phone numbers, we'll return both the ID and the number. And depending on how you export packages and stuff like that, this might make sense to be, maybe you need capital letters here so that the fields are exported. You might also want to make this whole type exported depending on what you're doing. Again, because all of this code is just inside of a main.go function, we aren't doing that. We're just, we can work with it all as unexported types. Up next, we're going to write code to update, delete, and find phone numbers by the actual value of the phone number. And we're going to be doing this because when we get to the for loop here, where we're normalizing our phone numbers and we're updating them, or updating the database with the new records, we're going to want to do it in a way that, well, we have to do it is how I should put it. We want to remove duplicates. So because we want to remove duplicates, we need to normalize the phone number. And if it has changed, then we know we need to update something in the database. Well, there's the chance that after we normalize it, it might be a phone number that already exists in the database. So because of that, we are going to need to look up the phone number in the database and see if it already exists. And if it does already exist, then we're going to delete the phone number we have. If it doesn't exist, we're going to update the one we have because we know that nobody else added that phone number normalized, or the normalized version of the phone number yet. So up here in this code here, where we're printing out the phone numbers as we iterate over them, this is probably going to change to something like, we'll say working on, and we'll print the phone number. And then we're going to say number is equal to normalize p.number. And then we're going to do something like if number is not equal to p.number. So we only need to do anything if the number is changed. So we could do an else here and say no changes required. So up here, we're going to go ahead and if the numbers have changed, we're going to say updating or removing. And we'll do just number here. Okay, so we're just going to run this, and we don't have any code in this update part, but we'll at least see the outputs to see what it looks like here. All right, so we're working on this number, no changes required. On the second one, where it has spaces, you'll see that we're going to need to update or remove it. And this same thing goes through for most of these. Any of the phone numbers that don't have any special formatting, no changes are required, but the rest will. I think there should be an example in here. I think it's this one is the same as the very first one. So we do have two phone numbers here that once normalized, they will match the same number. So we're going to need to make sure we handle that. Oh, and one of the reasons I do this if the number is not equal to p.number, instead of just always running this logic for updating, is that if you didn't check that, you might search for a number that already exists in the database and find the exact same record you already have. So then you'd at least have to do, okay, is the record I found the same one? Does it have the same ID as this one? So it's definitely worth keeping in mind that, you don't want to be doing that. Well, it's not that you don't want to do it. It's just this way is just as easy and it requires less database query. Okay, so we're going to start with finding a phone number. So I'm going to copy this get phone, paste it in here, and I want to find phone. It's going to take in a DB and a number, which is going to be a string. I know that sounds weird. Instead of returning a string, it's going to return a phone object. It's actually going to return a pointer to one. And it's returning a phone object because whenever we have these phones here, we want to make sure that we get the ID when we return it. We can't just return the number here. We want the ID and the value. Technically, we could just return an ID here if we wanted. I guess that would work fine. We could do int here. So that works too. Okay, so as we go through here, so we're going to do var ID int. I'm actually going to change this to be a phone. I think it makes more sense to return the phone object itself. So we'll say this will be a phone. And then we're going to query or select star from phone numbers where we want the value is equal to the number that was provided to us. And then if once we do that, we're going to scan and we're going to get the p.id and the phone's number, and we're going to scan those into these two fields on the phone number or on the phone object. So if the error is not equal to nil, there's two potential errors here, or there's more than two, but there's basically two cases we need to think about. If the error is the this error no rows error, then that means there was no errors actually querying the database, like nothing went wrong, but we just didn't find a record. So when that happens, you kind of have to decide what you want to do. You could have the find phone return a specific error no record type error. Another thing you can do is just return nil for both the phone and the error. I'm going to actually choose to do that right now just because I think it's simpler for what we're doing. But, there are cases where returning an error instead makes way more sense. So you pick and choose what works best for your situation. So here I'm going to say if the error is equal to SQL.error no rows, return nil nil, else return nil comma error. Otherwise, we're going to return the reference to the phone number we have and nil, or the phone object, not number. So now that we have that, we can go back up to our code, and here we can say existing is going to comma error is equal to find phone number. We need DB. If error is not equal to nil, actually here we can just put a must. And then we can say if existing is not equal to nil, then we need to delete this number, else update this number. So that's the two things we need to do from here. We either need to delete the number if the number already exists in our database, or if it doesn't exist in our database, we're going to go ahead and update this one. We can do either of these, so I think I'm just going to go ahead and start with the update. So for updating, we're going to be doing, I think instead of a query row, we're going to do an exec. We don't really need results from it, so I think it's fine to just go ahead and just call exec and run the command. And again, just like everything else, it's mostly SQL code for this part, and the rest of this is going to be the same idea of what we've been doing. So we'll just go ahead and start and say find or func update phone. It's going to take in a SQL.db, and it'll take a phone object, and it's going to return an error. I think that's the only thing we need. So this will say, actually we just need error colon equals db.exec. I think it just returns, oh, it has a result too. And we need a statement here. So we're going to do statement. This is update, so update phone numbers set. We don't want to change the ID. I think we just want to change the value. So we're going to say set value equals number. We're going to do number 2 here. Because the very next thing we're going to do is where ID equals number 1 or $1. So we want to update the phone numbers, set the value to whatever value we pass in, where the ID is whatever ID we pass in. When we exec here, I'm going to do statement p.id, p.number. So I did the ID as number 1 because generally speaking, when I write my SQL statements, I like to put the ID as the first argument if it's something that it needs. It's just sort of a habit that I have, something that I just tend to do, so it looks a little bit more consistent. And then we're going to say return error. So I believe that's everything for the update phone. We can up here do update phone db, and we can pass in this p object, the phone, but we want to go ahead and make sure that we've added the number. So we'll do p.number equals number. This is the updated number that's up here. We want to go ahead and make sure we set it before we pass in this update or the phone object. And we're going to do a must around this. All right, so next up is the delete. So func delete phone. And then we're going to pass in, we just need an ID for this. We don't need a full phone object because deleting, we don't need all the other data. And again, we're going to do a statement here. So we'll do delete phone numbers where ID equals $1. I think that should be right. So we're going to exec this statement, comma ID, return the error. So up here, we can go back to our code and do must delete phone db p.id. All right, so time to go ahead and test this and see what we got. I'm going to go ahead and leave all this debugging stuff for the time being, and then we're going to verify our data by connecting to the database in the terminal and selecting all of them and seeing what we have. And it looks like we have a syntax error. Where was this at real quick? So 159.64. It looks like whenever I call delete phone is where I'm getting the error. I'm guessing I wrote the SQL incorrectly. Yeah, I wasn't thinking. I need delete from. So we need delete from phone numbers where the ID is that. Now we can go run this and it should be fine. So it says that we've updated or deleted a lot of these. So I'm going to go ahead and connect to the database. Select star from phone numbers. And you'll see here that our output is a lot different than it was before. We've got IDs 1, 7, 2, 4, and 5. But more importantly, we've got the values where the last number is 0, 1, 2, 3, 4. So let's go back to this. And we're going to look at the expected output. And it looks like that is what we were expecting here. So it does appear that our code is working correctly. Now, I'm going to do one more video after this. And I don't know how long it'll be. But one more video covering the database SQL package. And what we're going to do in that is I'm going to refactor a lot of this. While I think this is fine just to, just throw some code together and just see how to get it to work, this is not how I design my code long term, and I think this is pretty ugly. And I also know that I'm going to be adding other implementations, using other database variants, things like that. So as a result, I want to go ahead and make sure I clean up this code so that as I go to those other different versions of this, the different variations, it's a lot faster. And it's also nice because you'll get to see how if you design your database, especially your database interactions correctly, you could sub out an ORM with just raw SQL, or you could sub out a SQL database with maybe some other variation of database. And while there are implications as far as indexing and database performance to consider, the rest of your application shouldn't have to worry too much about them. It should mostly just use functions like find phone or something like that that's available for it without having to get too worried about what database is being used. The next step is to refactor this. So to start, I'm going to create a DB package. I'm going to start moving this code over there. I'm going to start with the reset and create because I think this is the first thing we call in our code. And this is obviously one of the first things you'd probably want to do setting up your database. So you could actually set up the database, make sure your code's working. So we're going to start here. I'm going to copy these two and I'm going to make the directory DB. And then I'm going to add them DB. I'm just going to call this phone.go. So in here, we want package DB. I'm just going to paste this code so I have it to reference. So I'm probably actually just going to keep both of these functions. I know that seems a little off, but I think it makes sense for what we're doing here. And then what we're going to do is we're going to create an exported function called reset. And we're not even going to offer a create. Reset's going to handle dropping the database, creating a new one, and going from there. Because if you don't have a database, reset's fine because it only drops if it exists. Otherwise, if you're creating the database, you would need to reset it anyway. So I don't think we really need both to be exported. And this is going to take a definition very similar to the SQL.open. So if we go to the docs for SQL, let me see if I can find the open function. Here you can see that it takes a driver name and a data source. So we're going to try to keep this very similar to this. So if we swap out other SQL implementations, it's going to be the same as a SQL.open type call. And long term, if you were coding this for your own application, you could use functional options and some things like that to really give yourself a lot more flexibility. But I think for now, this will be fine. So we want driver name and data source for strings. And this is going to return an error if something goes wrong. So what this is going to do is it's going to db comma error colon equals sql.open. And this is the same as what we're doing in, let me go here, in the main package at the very top. We're going to be opening up this database here like this, except we're going to have all that data passed into us. So we're going to do driver name, data source. If the error is not equal to nil, we'll return it. Otherwise, we're going to reset the DB with this DB object, and then we're going to return db.close. And we need to catch this error, I think. Oh, we need to pass in a database name. So maybe up here, we'll go ahead and add db name. We'll do db name, and we're going to capture this error. So error equals this if the error is not equal to nil. All right, and you'll see here that I'm returning the error from db.close. I'm doing that because reset, there's no real reason to let them keep the connection open or anything like that. Resetting a database is going to drop it, recreate a new one, and chances are once they set up the database, they're going to want to reconnect with that database specifically. I just think it's fine to just drop the connection in this specific case. All right, so let's go back to our code, see if we can make this work. We've got this first line keeps the PSQL info. We want to keep that. We're going to go ahead and do must db.reset. This is going to be Postgres is the driver name, PSQL info is the data source, and the DB name is the DB name constant that we have at the top. So we can delete all of that, and let's see what we're getting errors about. Undefined DB. So we've got DB here as our package. So the real question is it imported? All right, so if I import DB there, let's see if that works. Okay, so one of the issues we're going to run into, and we'll eventually get rid of this, but for now it's going to cause an issue, is the fact that we're declaring things as DB. Actually, that's not an issue. So from this point onwards, inside of main, DB refers to a variable. But prior to then, it refers to a package, which is a little bit confusing, but I think in this case it'll be fine, and we'll probably get rid of some of this. But if it is something that bugs you, you could do something like phone DB, something like this. Come down here and put it in. And we can actually just do that moving forward so that we always have access to both. Okay, so next thing we need is, what are we doing in here? Looks like the next thing we do is create the phone numbers table. So we're going to want some way to do this. I think it makes more sense to just call this something like func migrate, and it's going to return an error. And this will just handle setting up the database, I think. You know, it'll go through, figure out what tables are there, which ones it needs to create. Things like that is what I would generally put in something like this. But, I mean, there's different migration techniques, but for now I think it's fine to just go ahead and take this create phone numbers function, because it's a really simple migration, and just copy this and delete it from here. I'm also going to delete reset DB and create DB. Then I'm going to paste this in here. We can take most of this code. So for migrate, I think we're going to take the same definition as reset. We're going to take in driver name and data source. We don't need the DB name because the data source should have that at this point. So we're going to do this. It's going to be a string. And this create phone numbers, I'm going to create or leave that as its own function, I think. And I'm going to copy a lot of this code. And then I'm going to do create phone numbers table with the DB. We're going to say if error colon equals, error is not equal to nil. Actually, I could probably just do error equals this if the error is not equal to nil. I'm only doing that because the error variable is already declared. It's just as easy. And then after that, we want to return db.close. All right, so assuming that all worked correctly, we should be able to migrate our database with this package now. So let's go back to main and see if we can replace that. So around here, we're going to want to go ahead and put something like, we don't need to do this opening stuff, so we can actually get rid of that. Although I'm going to leave it just so it doesn't break our code for the time being. And then here, we're going to do must phone db.migrate, Postgres, PSQL info, and that's it. Okay, so assuming that all worked, I want main.go. All right, it looks like this is still working as we expected. So we're going to go ahead and work on the next part. We're going to want to take a lot of these methods that we have, or they're not methods now, they're functions, like insert phone, get phone, all phones, that sort of thing. We're going to want to take those and move them into our DB package. And we could make them accept a DB object, but I think it makes more sense if we want to be language agnostic to just go ahead and create a type inside of our database package. And that type will have some methods on it that, you know, once you set it up, you know, it's kind of like SQL.open. Instead of calling SQL.open.exec or then taking the DB and calling it exec, we'll call db.open, open up a database, and then later we can call db.insert phone or something, and it'll be a little bit simpler. So that'll make more sense here in a second. We'll start with the type, which I'm going to call DB. I don't love the mimic name here, the double name, but I think it's fine for what we're doing right now, especially since the package name makes sense to me. SQL, I don't know if I'd love, and I don't want to name this SQL or something because I think that's well, it's not that you couldn't do it. We could name it SQL and then, maybe not export it and use an interface that we're actually returning. But I think for now, it's fine to do DB. So DB is going to be SQL.db. So that's inside of this struct type. And then we're going to add some functions to this, or some functions and methods. So function, open, driver name, data source. These are strings. And this is going to return a DB or an error. So here what we're going to do is take a lot of this code here, paste it in. And if there is an error, we're going to return nil, error. Otherwise, we're going to return DB and DB with nil for the error. All right, so this opens up a connection to our database using our new database type. And then we're going to want a close function, or technically this one's going to be a method. So we're going to go ahead and do close, and this returns an error. And this is going to return db.db.close. If we needed to do anything else specifically to close, we could do it in here, but I think this is plenty. Just having it return, this inner database, once we have that connection, we're going to want to close that. So going back to our code here, all of this is going to break. So I'm just going to go ahead and just comment it all out for the time being. So we're going to do db, error, equals db.open. This is technically phone DB now. Postgres, data sources, PSQL info. We're going to must error, and then defer db.close. All right, so the first thing we do here is insert a bunch of phone numbers. We're going to need an insert phone number method, but I think for this, realistically, this is all seeding data. I don't see a reason to export an insert phone function right now, and we're not using it anywhere. So it might make sense just to go ahead and seed it. And then later, if we do decide that, we need to add an insert function to this, well, we can add it, and any code that needs it, it shouldn't break it. Adding a new method isn't going to break that code. So I'm going to go ahead and copy all of this. And I'm going to go in here, and I'm going to start func db seed. I'm just going to paste this inside of here and have this return nil for the time being. And then I'm going to look down here for the insert phone. There it is. I'm going to grab that, come back over here, paste it inside of here. So this won't be exported, but it's going to know how to insert phone numbers into our table. All right, so now that this should all still work too. It's all the same exact code as long as we pass in the same stuff. So up here, I'm going to refactor this a little bit as well. I think it makes more sense, instead of doing a bunch of musts like we did before, to make this all a slice of phone numbers we're going to insert, and then iterate over them and return an error if we get one on any of them. So I'm going to do some multi-select magic. All right, so paste these all, and then I want this plus a new line. All right, so there's those. So I'm going to do commas at the end, and then I'm going to say data is a string slice with these entries. And I'll save it so that it formats a little bit nicer. And then I'm going to do for underscore, because we're not using this. Then each one's going to be a number in the range of data. And then inside of this is where we're going to say insert phone, db.db number. And then we're going to catch this error. So if error equals error is not equal to nil. So I think this is what we want here. And insert phone returns an ID. We don't need that though, so we can just put underscore here to capture that. So that's everything for seeding. So now we can go back to main. We can delete this insert phone. We can scroll up here. This whole section is what we were trying to replicate. So we can delete this all. And we've actually already done this connection stuff. We've already got that done. So here I can do if error equals db.seed, error is not equal to nil. And you can see that as we refactor this and clean up the code a lot, this must becomes a lot less useful. I could do error equals this, must error. So I can use it again still. But I think that when you start designing your code well, you tend to need things like this a little bit less often, especially if you try to actually handle the errors. Here I'm just sort of panicking with them because we're in the main function and it's just a quick sample. But sometimes you might want to try retrying and stuff like that too. All right, so the next thing is getting phone numbers by ID. I don't think we actually end up using this in the final version. So again, I don't know that we need this. I'm just gonna go ahead and just get rid of it. This part here, I'll put it in here, I guess, just so it's there. And I'll put a comment that says, we don't use this right now. Because I don't think we're using it at all. All right, next thing is iterating over all the phone numbers in our database and getting them returned. And this is where we're gonna actually return a phone type as well. So if you scroll down here, you'll see that we've got the phone type and the all phones. I'll copy both of those. And inside of here, inside of our database package, we're gonna want some way to, we need to, like this phone type, it needs to be declared in some way. So usually when I'm doing my own database packages, where you declare the actual models and that sort of thing you're working with, it varies to pace. There's a bunch of different ways I've seen it done. One of the ways I tend to like to do it is to define my data layer, my model layer, and stick everything in there. And then not have that dependent on anything else. So that package doesn't depend on other handlers or anything like that. All that stuff depends on this package. So if you design it correctly, you can put all the models inside of that data layer and then just sort of pull them from there. But it really can vary at times. And I should also mention that to do it well, you normally have to put all of your models inside of one big package, which some people just dislike. All right, so we're gonna go ahead and just declare the type up here. Pasted it in here. It's going to be the phone type, and it's going to take an ID and a number. And we'll just say phone represents the phone number model in the database. Or we'll just say phone number table. I think that's fine. I'm not commenting everything. I just did that one because I think it's usually these are the models I like to sort of make sure they're at least documented. Even in quick videos like this, I try to. All right, so we need this function to get all the phone numbers. We have this. We can keep it as is. Coming down here, I can paste. I don't want to paste it there. I'm going to go ahead down a little bit. I want to do it right above migrate, I think. Yeah, I think that's fine. I'll save to reformat. I'm going to go up top and get rid of the one that we didn't have it. Okay. And I'm not sure what the error is going on here. Oh, it doesn't know about this type. That's fine. So we got to change this to the exported phone type. And then for a lot of these, we're going to tweak a little bit of the code here. So this is going to be phone. This is going to be a phone, capital P. And this is going to be ID, and this number is going to be an exported field. I think that's mostly everything. All right, so now we want to make this a method on our DB type. And we're going to say all phones. And it's not going to take in any arguments. It's going to return a phone slice or an error, just like this one. And here we could do all phones, DB, and just return whatever this gives us. But knowing that we're not doing anything else, we're just calling this other, unexported function. If you want, you can, pretty much just as easily just do this. And the only real difference here is that here you have to do db.db for the query, and I think the rest of this is exactly the same. Okay, so we've got the all phones there. Coming back to our main, we can scroll up here. I think the phone type is now gone, so it's going to complain for a bit, but that's okay. I can comment those two out. Comment this out too, because we're not using it. And up at main, we're going to go ahead and say phones, error is going to be db.allPhones. Must error for each phone in the range of phones. We're going to do all of this stuff we were doing before. So I'm going to grab all of this code. uncomment it, save it to reformat it. And a couple things are going to need tweaked here. Most notably, a lot of these are exported fields now, so we got to tweak them a little bit. And this find phone is not going to work. So I'm just going to copy or comment all of this out for the time being. And no changes required. That's the same section. So I think at this point our code should compile and run. So we're going to go ahead and try that. All right, so it looks like it's working. It's definitely doing the working. It tells us whether it's updating or no changes are required. So now we just need to go ahead and get the update, delete, and find functions working, and we should be refactored. So the same idea is going to apply for find, delete, and update. We just want to call something like db.findPhone number, and then we want to do existing error is going to be something like this. Must error if existing is not equal to nil. We have to delete, that's what. Must db.delete phone, and we'll do p.id. Else, we would do something like p.number equals number, and then must db.update phone, we'll just pass in the phone then. And I think p is not a pointer, so we actually didn't do that down here. One of the things I will mention that's pretty common is if you have an update phone number or an update function in your database stuff, a lot of the times, instead of returning an updated phone object, what will happen is you'll pass in a pointer here. So it'll be something like this. And this object can be just edited inline so that any of the updates or changes can be just updated to reflect on there. So maybe a created at number or date time or something like that gets changed. Not created at, usually be like an updated at date time might get changed. And it could be updated in this object so that you don't have to return it as well. So I'm going to assume that we're probably going to be passing in a pointer here. So I'll do and p. And then I think that's it for this. So none of this code works because we don't have the find phone, delete phone, and update phone. But I'm going to go ahead and comment it out, and we're going to make this all work. So we're going to start with find phone. That's this one. I'll copy it. Go here, and we'll go ahead and just paste in this one so we can uncomment it now. And we can do func db find phone, takes in a number, which is a string, and it returns a pointer to a phone and an error. And then from here, we want to go ahead and do all the stuff we were doing before, except we'll want to tweak the code just a little bit. So I'm going to go ahead and delete all that to make this all one function. Make this a phone with a capital P. And then here, we need to change this to ID number. This DB needs to be db.db because this right here is the DB object we created. So we need the field in it that's the SQL DB. All right, so that's everything here. And again, if you were doing the error stuff that I mentioned before where you returned a specific error, here you might return something like, you might have something like var error no record. And you might return that here. So you could do errors.new, and I'm just gonna leave it blank for now. And the reason you would do this is you don't want to return this SQL error, even though people could look at it and know what it is. It's not database agnostic at this point. So they have to know you're using SQL behind the scenes for this to work. Now, we haven't completely extracted all the SQL stuff from our code, specifically up here when we do the open. You'll see here that, obviously they have to know a little bit about that we're using SQL here, but at some point you could pull all of that out. You could use functional options and things like that to really make it so that you have different databases supported with your code, and they can use whichever one they want. So, it's something to keep in mind. But for now, I'm going to go ahead and just return nil like we were doing from the get-go. So that's our find phone. And before we move on, I'm actually going to do something here. I'm going to import github.com/lib/pq. I tend to import these into the phone, like my database package, just so that people using that package don't have to think about it too much. You don't have to. Technically, if we didn't do this here, any code that called this could just import whatever SQL data or implement driver, that's what I look for, They could import any driver they wanted, and this package should pretty much just work with any of those drivers. But since we know a lot of this code, there is at least a little bit of it here, this returning stuff that is SQL Postgres specific, it might make sense to put it there. Okay, I'm going to go up here. This should be working. Same with this. All of this should be working. We just need the delete and the updates. So I'm going to go ahead and come down here and find update first. Actually, we'll get both. Copy them, delete them. And come back to the phone, the database package. And where do we want to put these? I think we'll put them above migrate so they're with the rest of the methods. I'm going to uncomment these, and I'm going to go ahead and make this. I didn't mean to get rid of that, but that's okay. Func DB. This is going to be update phone. And this is going to take in a pointer to a phone object. It's going to return an error. So we're going to update the phone number, set the value, where the ID is equal to this. This gets changed to be the exported fields. And this needs to be db.db. Aside from that, this should all work the same. And then the same idea here. So delete phone. And I don't know if I've mentioned this, but the reason we can get rid of all these first arguments that are the database is because since these are all methods on the DB type we have, they already have a database connection there that they can use. So we don't need to pass in that database object every single time. And I think this one, aside from db.db, stays the same. Okay, so going back here, we'll just save that with those two. We can get rid of all of this, I think. And I think if that's all right, our main function is now much simpler. We reset or migrate, we open up the phone DB object, and then from there we defer closing it, seed it, get all the phones, and work on them. So let's go ahead and run this again. And everything seems to be doing what we're expecting. So we can also connect to the database. And we can query this, and you'll see that all of these are exactly as we expected. In follow-up videos, I plan on showing you how to do all of this. We'll be mostly working inside of this phone.db or phone file here in the DB package. And we'll start subbing it out with different packages and showing you how most of the code in main shouldn't really change. It should mostly stay the same.